Here we go, ladies and gents. Test tomorrow, 5154, yes? You will be given on a big sheet of paper on your desk the trig identities, the unit circle, and all the sum and difference formulas, okay? No memorization needed there. You will have I think there's 10 questions. You guys are going to ask me. I can't make this test super long because a lot of these things are involved. So you have probably one simplifying, one verifying, and then the rest, all the different kinds of solving stuff. So let's just go over the verifying quickly, please. Again, you should have your identities in front of you. I don't have them pulled up here, but I have them next to me. Secant squared, 1 minus sine squared. Both of those, right, have squareds in them. The 1 minus sine squared should set off some bells and whistles because it's a trig function squared that's attached to a plus or minus 1. Camilo. 1 minus sine squared is the same as cosine squared. Perfect. And then over here, I still have my secant squared. You could have broken that down already if you didn't. But with secant squared, it's going to be the same as what, ladies and gents? 1 over cosine squared times cosine squared over 1. And what do we see happens with our cosines? They cross off. So I have 1 equals 1 is what we were trying to do. Remember, 1 equals 1 is not your answer. Your answer is the meat in here. And again, if you guys just put down nonsense, I will go through and make sure that it makes logical sense. You'll get points for the parts that make sense. Now, number 2, I had some people email me, I cannot figure this one out. It's because on my end, I forgot to put the squared on yours. I realized it when I was doing my answer key, and then I thought I put it on your original. So if you had issues with this one, I didn't see my note about making it tangent squared. That's why. But again, I look at secant squared minus 1. That's a trig function squared with a plus or minus 1 attached to it. Does that equal anything? Look at your trig identities.
Tangent?
What is it?
Tangent is 1 over cotangent.
Okay, tangent, you can make 1 over cotangent. True.
And the cosecant squared minus 1 is also cotangent squared.
It's cotangent squared. I agree. This is cotangent squared. And Raul told us that we can make tangent 1 over cotangent squared. Correct? What do you notice happens here? They cross out. I get 1 equals 1. That's not the way I did it. But you can absolutely do it that way, but that's not the way I did it. Julian, what'd you do?
Well, they're both, so tangent is sine squared over cosine.
That's what I did. That's how my brain works.
Yeah, and then cotangent is cosine squared over sine squared, so they cancel out.
So this becomes cosine squared over sine squared. And what do those two things do? Cancel out. Is that the exact same thing? Yeah. Does that make logical sense? Yeah. Either one of those would be fine. Yes, sir. All right, let's look over here. Again, we have a bunch of squareds. I have a trig function squared that's attached to a minus 1. Is there anything that's going to help me out there? There's something with secant and tangent and all that good stuff? What is secant squared minus 1 the same as?
Tangent squared.
Tangent squared. This is the same as tangent squared. Remember, you will be getting your identities, so don't worry about it. Now, what can I change cosecant squared into? 1 over sine squared. Well, darn it. These don't just cancel out like we were hoping they could. What's something else I could do? I can convert tangent squared to sine squared over cosine squared. Okay, agreed. Now what? Sines cancel, so I have 1 over cosine squared. Now, what am I trying to get to? Secant squared. Is there a relationship between 1 over cosine and secant squared? They are what of each other? Good word. Good job. So secant squared equals secant squared. Now, on day 1 and 2 and 3, when we did this, it sounded horrible. You guys sound 1,000% better.
I did it a little differently.
Did you get the same answer?
Yeah.
Okay. And that's okay. This should be written somewhere. If you guys don't have this committed to memory, you need to write this down right now and look at it tonight. Make sure you know sine, cosine, tangent, secant, cosecant, cotangent. Know what they are, okay? You will not be given that on your test tomorrow. But the first thing I'm going to do here is it says to solve, all right? We're solving over the interval of 0 to 2 pi. It's going to say it on your questions. I'm just looking for one trip around the unit circle. That's it. I told you guys a little thing you can do. You want to isolate the trig function with the x. Is this a multiple angle question?
No.
No. How do you know if something's a multiple angle question?
We'll have like a number in front of the x.
As a number in front of the x. Good job. So all I'm going to do here is isolate tangent squared. What do? I'm going to add 3 to both sides. I get tangent squared of x equals 3. I'm not looking for tangent squared. I'm looking for what? I don't want tangent squared. I want just the... How do I get rid of the squared, guys? Take the square root. When I physically take the square root, what goes in front of my answer? Okay, so I want plus or minus root 3. What is tangent? Remind yourself. What over what? Y over x. Or sine over cosine, however you want to look at it. We're dealing with all of these ordered pairs that are on the unit circle. So where on my unit circle, look in the first quadrant and then figure out all the other ones, where could I take the y value divided by the x value and get the square root of 3? Pi over 3. So x equals pi over 3. What is the ordered pair at pi over 3? 1/2 and square root 3 over 2. So I want all the values on the unit circle that give me either positive root 3 or negative root 3 for my tangent. So there should be 4 of them. It's all of the ordered pairs of the unit circle that have 1/2 as the x value and root 3 over 2 is the y. Just a different combination of signs. So it's pi over 3. What else? 2 pi over 3. What else?
4 pi over 3.
Good. 4 pi over 3 and 5 pi over 3. All 4 of those answers are what I'm looking for. All right, let's scoot along. If I'm going too quickly or something, just let me know, guys. But I want to try and get through as much of this as I can. Whatever I don't get through, I'll finish on a video and upload. But what do you notice here? Okay, this is a tad bit different because there's cosines where? On both sides. So just treat this like any normal algebraic equation where you want variables on one side and numbers on the other. So what do you want to do?
Add 2 cosine.
You want to add 2 cosine theta? Now, again, if you want to change everything to x's or whatever, that's totally fine. If I have 2 cosine thetas plus another 2 cosine thetas, I have a total of 4 cosine thetas, good, plus 4 equals 0. Trying to get cosine theta all by itself. Subtract 4, good. So 4 cosine theta equals negative 4. Last thing. Perfect, divide by 4. So I'm saying I want all the places on the unit circle where the cosine of theta is negative 1. What is cosine? What value? X values. Where on the unit circle are all of or any x values negative 1? Yes, sir. What is it?
Pi.
X equals pi. There you go. All right, same type question. It's just a different trig function. So what should I do? You can add 2 sine theta. Good. Okay. Could I have just subtracted it from the other side too? Okay. Again, whatever you guys want to do. So 4 sine of theta plus 2 equals 0. Now what? Subtract 2. Good. So 4 sine of theta, all right, equals negative 2. Then what? Divide by 4. And I get sine theta equals negative 1/2. Is that my answer? No. That's giving me direction on how to find my answer. That's telling me, hey, look at where on the unit circle? Y values. Sine is y values. So look on the unit circle for all of the sine values, or that y, that's negative 1/2. What is it? So 7 pi over 6 and
11 pi over 6.
11 pi over 6. Does it matter if I put 11 pi over 6 first?
No.
No. This could happen tomorrow. What if it said, just saying, it said sine theta equals 5?
Then it's not this.
Is there any place on the unit circle that your y value in an ordered pair is 5?
No.
So you would tell me undefined. That could happen. It's not that there's no answer. There is an answer. You just have to use your calculator to find it, and we're not doing that right now. But that is a possibility. So don't just think, oh, geez, I did something wrong. Trust yourself. You guys know how to do this. You're fine. All right, here we go. Now what? Whoa, what's wrong with my thing? Okay, here we go. Sorry. I moved, but it didn't. Let's get tangent squared of x by itself. So what do? We subtract 3 from both sides. Tangent squared x equals 1. Okay? I take the square root. When I physically take the square root of something, what goes in front of my answer? Plus or minus 1. Good. And tangent's what again? Y over x. Now, yesterday, some people were asking me questions, and they were going around the unit circle, and they were saying, okay, it's either at 90 or pi or... No. How do you get 1 when you divide two things? Something by itself. So you're looking for the ordered pair. What's that ordered pair that's the same for the x and the y? Root 2 over 2, comma, root 2 over 2. So where on your unit circle can I take the y value divided by the x and get the number 1? 5 pi over 4, yeah. Where else? 3 pi over 4, yep. Pi over 4, and? Perfect. Good job, guys. All right, how is number 8 a tad bit different? There's a 2. Look, this is a multiple angle problem because there's a 2 stuck right here. Can I divide by 2? No. I cannot separate, excuse me, the trig function and the variable. So that's just this one extra step I have at the end. So what I'm going to do here is I'm going to look and I'm going to say, okay, cosine. What's cosine again? What values? X values, okay? So let's look in the unit circle, find all the x values that are negative 1/2. What are they? 4 pi over 3?
Yeah.
Okay. And? 2 pi over 3? Okay, now look how I wrote this. I'm writing 2x equals. Because it's not just x equals. So we have one extra step. What do I have to do to get x all by itself? I'm going to divide by 2, and I'm going to keep, change, flip. Now, guys, my suggestion to you, just as a little reminder, I would put this over 1. So you remember to actually flip. We're going to keep 4 pi over 3 the same, change division to multiplication, and flip. 2 over 1 is going to become 1 over 2. So 4 pi over 3 times 1 over 2 gives me 4 pi over 6. Do I leave my answer like that?
No.
No. What does that reduce to? 2 pi over 3. Always simplify, ladies and gents. Same thing here. We're going to divide by 2. So 2 over 1. I'm going to keep, change, flip. So 2 pi over 3 times 1/2 gives me 2 pi over 6, which reduces to pi over 3. Can you put 1 pi over 3? Yeah, sure. Let's keep scooting. Good job. You guys are doing awesome. Same thing. Is this a one angle or are we talking about multiple angles? It's multiple. So let's get, if you need to, bring colored pencils or a highlighter or something. You can borrow mine tomorrow. But you want to isolate that trig function. So there's 2 things we need to do. What are they? I'm going to add 1 and? Good. Add 1 and then divide by 2. Good job. So sine of 3 theta equals 1/2. Sine, again, ladies and gents, is the y values on your unit circle, yeah? Where are my y values? Positive 1/2. Okay, so I'm going to write 5 pi over 6 and pi over 6, right? So 3 theta equals 5 pi over 6 and 3 theta equals pi over 6. Divide both sides by 3, which is 3 over 1. Keep, change, flip. So 5 pi over 6 times 1 over 3, yes? So theta equals 5 pi over 18. Good. Again, divide by 3. Keep, change, flip. So pi over 6 times 1 over 3. Theta equals pi over 18. Wonderful. Okay, same thing on 10. Let's go to 11. Again, I posted all of the answers, so they're all there for you guys. If you have any questions tonight, just send me an email, whatever comes to me in the morning. But I want to make sure I touch upon everything. So what do we notice about this problem?
Quadratic.
It's a quadratic. Do I have different trig functions or the same trig functions? The same. So we just factor this like we normally would. We don't have to worry about converting anything. So I'm going to talk about what trig function times itself gives me cosine squared. Cosine, right? Someone put cosine x, cosine x. Now think about this. 2 times negative 1. What are the factors of negative 2 that multiply to give me negative 2, but add to give me a negative 1? Minus 2 plus 1. Perfect. Last thing we have to do for factoring, since my a term is not 1, I'm going to divide both factors by the a term. So this becomes cosine x minus 1 equals 0. This 2 is going to come out in front here. So I have 2 cosine x plus 1 equals 0. Questions? Morning. So now I'm going to add 1 to both sides. So I get cosine x equals 1. On the right-hand side, do you guys agree with me? I'm going to subtract 1 and divide by 2. So this becomes cosine x equals negative 1/2. Cosine are what values?
X.
So x value here, x value here. On the unit circle, guys, where is the x value positive 1? At where?
2 pi.
Okay, some of you might want to say it's at 0. Some of you might want to say 2 pi. So I would take either 0 or 2 pi. Either answer. You do not have to put both. Where on the unit circle are my x values negative 1/2? 2 pi over 3 and? Perfect. So for this problem, we had 3 answers. 12 is the same kind of problem. It's a quadratic. Both has the same trig function, right? Again, I posted the answers so you guys can look at that. Let's do 13 and 14. How is 13 a tad bit different than what we just did? There's 2 different. Right? I told you guys, if you have a quadratic with 2 different, you want to convert to the middle. Is there a Pythagorean identity that can help me convert cosine squared to sine?
1
Yeah, you're right.
minus. 1 minus.
Okay. I can rewrite cosine squared as 1 minus sine squared. Correct? You're always going to convert to the middle, guys. I will give you something that you can check your Pythagorean identity and make the conversion easily. Now this just becomes a basic algebra problem. What do I do with that 2 out in front? I'm going to distribute. So I have 2 minus 2 sine squared x plus 3 sine x minus 3 equals 0. Can I combine anything?
2 minus 3.
Okay, 2 and negative 3 gives me negative 1. So watch, I have negative 2 sine squared x plus 3 sine x minus 1 equals 0. Can I factor this just yet? I'm going to take out that negative 1. I have to factor out that negative 1. We don't like to factor when we lead with negative. So I'm going to take out that negative 1, and then I'm left with 2 sine squared x minus 3 sine of x plus 1 equals 0. It just changes all the signs. So at the end, when I set each parenthesis equal to 0, when I say negative 1 equals 0, it's not true. So we're good. So again, keep your negative 1 out there. What are the trig functions that I multiply together to give me sine squared? Sine times sine, right? Sine x times sine x. Good. Multiply a times c. What are the factors of positive 2 that multiply to give me a positive 2 but add to give me a negative 3? Negative 2 and negative 1. Good. So since my a term here is not 1, it's 2. I'm going to divide both terms by 2. So I'm left with negative 1 equals 0, which is not ever going to happen. I'm left with sine, whoops, forgot to write the word. Sine x minus 1 equals 0. Where'd I get 1? 2 divided by 2, okay. And then this 2 is going to become a coefficient, so I get 2 sine x minus 1 equals 0. So on the left-hand side, you guys agree I'm going to move the 1 over. I'm going to add it. So I get sine of x equals 1. And then on the right-hand side, I'm going to add 1 and divide by 2. So sine x equals positive 1/2. Sine is what value? Y value. Do you guys see why we can't have like 20 problems on your test? Some of them are a little lengthy. Where on my unit circle are my sine, my y values, excuse me, positive 1/2? What is it? Okay. And 5 pi over 6? What else?
And for sine x equals 1 is 1. I mean, yeah, it's pi over 2.
Pi over 2. There you go. There's our two answers. You can put them separately if you want, or you can put them all together. Doesn't matter. All right, 14. Same kind of problem. I need to change, right? I had to change one of my trig functions where it was convert to the middle. So what's another way I can write sine squared, but in terms of cosine?
1 minus cosine squared.
Okay, so negative 2 on the outside here. I have 1 minus cosine squared theta plus 3 cosine theta plus 3 equals 0. What do I do with that negative 2? Distribute it. Good. So negative 2 times 1 is negative 2 plus 2 cosine theta, right? Plus 3 cosine theta plus 3 equals 0. Can I combine anything? Negative 2 and a positive 3. So I have 2, excuse me, cosine theta plus 3 cosine theta plus 1. All right, we factor. Cosine theta times cosine theta. Yes? Factors of positive 2 that multiply to give me 2, but add to give me 3. Plus 2 plus 1. What do I have to do with my a term? Divide. Good. So let's move up here. We have cosine theta plus 1 equals 0. And cosine theta what? 2 cosine theta plus 1 equals 0. Move 1 over, it becomes negative. So I'm looking for where cosine is negative 1. And I'm looking where cosine is what? Negative 1/2. What are my cosine values? X. What are my answers, ladies and gents? 2 pi over 3. 4 pi over 3. And?
2 pi.
And pi. Well, my x values be negative 1. All right, this question, these two that we're going to do, 16, 17, it says use the sum and difference identities, equations, however you want to say it, to solve. Find the exact values. That means you're going to have an exact value. You guys don't have calculators. You're not going to have, you should have some sort of square roots in your answer. But this is telling you exactly what to do here. It's telling you to use what formula? The cosine formula when you're doing what to the two angles? U minus V when you're subtracting them. The first thing you should do is look to see is 11 pi over 6 and or 3 pi over 4 on your unit circle. Is it?
Yeah.
Yeah, guys, before you can go ahead and convert. But look, just give it a shot just to see if it's there before you take the extra time to convert. If you convert it, you would easily see it is, but where on the unit circle? I'm going to write it in degrees so it's a little easier for us to see. What is this saying? What's 11 pi over 6? 130. Minus, what's 3 pi over 4?
It's 330.
330?
Yeah,
11 pi over 6.
Oh, 11, I'm sorry. 11 pi over 6 is 330. Minus 3 pi over 4 is what? 130.
35.
So 135. My ears are not working today. So here is my u, here is my v. Again, how you guys set this up is up to you. I'm just showing you what I think is the easiest thing to do. What is the ordered pair for 330? What's the ordered pair? Square root of 3 over 2, comma what? Negative 1/2. Be really careful with your negative signs. What is the ordered pair for 135? Look at your unit circle. Come on, guys. 135. Negative square root of 2 over 2. And what? Positive square root of 2 over 2. Now, take another second to remind yourself that the x value is your cosine. The y value is your sine, right? Get everything set up so you don't really have to do much other than look. Now, you're going to have the formula on a sheet in front of you. So, guys, tell me what to write. It's cosine u minus v. So, tell me what it is. Cosine what? Use the degree measurements. Don't put the numbers in yet, but what's the formula? Cosine u times cosine of v plus sine u times sine of v. Please be careful with the cosine formula. Now let's just fill in. Cosine is x value. So what is the cosine of u? Root 3 over 2. What is the cosine of v? Negative root 2 over 2, correct? Plus sine of u, negative 1/2, sine of v, root 2 over 2. Agreed? All right, so square root of 3 times negative square root of 2 gives me negative square root of 6. And 2 times 2 is 4, correct? And then I have plus negative 1 times root 2 is same as minus, right? Square root of 2 over 2 times 2 is 4. So if I rewrite that with one denominator, what does it become? Negative square root of 6 minus the square root of 2 over what? 4. That's it. All right, when they give you a problem like this, check to see if those given angles are on the unit circle. If they're not, just convert. That's okay, but check to see first. All right, let's look at the next one. 11 pi over 12. They want me to use the sine formula, but they want me to find the exact value of 11 pi over 12. Is 11 pi over 12 on our unit circle? No. So how do I convert it? Pi goes on the bottom, 180 goes on top. Now you guys say, oh, I don't have a calculator. That's okay. We're in an honors math class. We can do this. Pi's cancel out. What number goes into both 180 and 12? Okay, 6. 6 goes into 12 twice. 6 goes into 180 how many times? 30, okay. Can I simplify a little more? Yep. 2 goes into 2 once. 2 goes into 30, 15. So, ladies and gents, what is 15 times 11? So, sine of 165. Check your unit circle. Is 165 on your unit circle? No. Are there two angles that you could add or subtract to give you 165? Yes or no? Yeah, what are they? There's a bunch. 135 and 30, okay. 135 plus 30. I need to check my answers. I think I subtracted on my answers. I used 120 and 45, but I think I subtracted for whatever reason. But that's fine. It does not matter as long as the two numbers add or subtract to the angle you're looking for. So let's go through this again. Here's my u, here's my v. U is my 130 degrees. What is the ordered pair for 135 degrees? X is negative, y is positive? Okay. And what about my v? My 30. Square root of 3 over 2 and 1/2. Good. So again, remind yourself, all right, this is my cosine value. This is my sine value. And then tell me the formula. What are we doing? We're trying to find sine. And what are we doing to the two angles? We're adding them together, right? So I'm going to use the sine formula that I'm adding the two angles together. So tell me what it is. Sine what? Sine u times the cosine of v plus cosine of u times the sine of v. Again, those will be given to you. So now we just fill in. Sine of u, root 2 over 2, times cosine of v, root 3 over 2, plus cosine u, negative root 2 over 2, times the sine of v is 1/2. Did I write that in right? Okay, so this becomes the square root of 6 over 4. Yeah? And then I have minus square root of 2 over 4. So my answer is square root of 6 minus the square root of 2 over 4. Is it similar to the last answer we had? Yeah, a lot of these answers are going to turn out to be similar looking. That is okay. That is what your answer should look like. All right, this next set of problems, I purposefully didn't go over this on your WebAssign stuff just to see if we could figure it out. Guys, this is super duper easy. A lot of you made this much harder than it needed to be. You're going backwards here, right? You have your sum and difference formulas in front of you. So this says to write the expression as sine, cosine, or tangent and find the exact value. So the first thing you do is you look. What formula, on your little formulas, everybody look at them. What formula goes cosine, cosine minus sine, sine?
Cosine u minus v.
Cosine u minus v or cosine u plus v?
Minus v.
Okay. You tell me.
Plus.
Is it plus or minus?
Plus.
Okay. So in your mind, you guys are like, okay, look, this is cosine of u, of u plus v, correct? Okay, so in this case, guys, what is the u angle? 50 plus what is v? 10. Can everyone add? Yes. What is this question really saying? Cosine of 60. Here's the first part of your answer. You wrote that formula as a sine, cosine, or tangent expression, correct? And now you're going to answer the question. Cosine is what value? X value. So what is the x value at 60 degrees? That, ladies and gents, is the entire answer. You're going to write the formula that is given to you as one trig function. You have the formulas excuse me, in front of you. And then you find it on the unit circle. Some of your WebAssigns gave you wackadoodle numbers that weren't on the unit circle. I understand that. That will not happen to you on your test. So moving along, you might have one of these, guys. Tangent. Which tangent formula, there's two of them, has a minus in the numerator and a plus in the denominator? Tangent what? U minus v. Okay, this is how you would show me your work. So I'm going to say tangent of, well, u is 100 minus v is 70. So this written as one singular trig function is the tangent of what? 30 degrees. And now you're going to tell me what it is. Tangent is y over x, correct? Well, what's the ordered pair at 30? Square root of 3 over 2 and 1/2. So I'm going to take y 1/2 over my x, which is root 3 over 2, correct? Keep change flip, so 1/2 times 2 over root 3, 1 over root 3. What's my answer? Root 3 over 3. You got to rationalize. That's it. All right, scooting along, scooting along. Which formula says sine, cosine minus cosine, sine? Sine of u minus v. Okay, so this is the sine of 315 minus 15. So I'm looking for the sine of what? 300. Now, very easily, if you guys weren't paying attention and you said, oh, this is sine of u plus v. Well, what's 3 of 15 plus 15? 330. Is 330 on the unit circle? Yes. So very easily you could get this question wrong if you're not paying attention. But here we're written as one trig function. Sine is our y value. So what is the y value at 300? Negative root 3 over 2. Perfect. Okay, I worked both of these out. On your answers. They're already posted. I'm going to do 22. If it doesn't tell you what quadrant it lies in, but it says it lies between pi and 3 pi over 2. Just draw yourself a little picture. Where is pi? Right here. 3 pi over 2 is here. So what quadrant is this? 3. It's important. That little piece of information is so important because it tells you the signs, S-I-G-N-S. And in quadrant 3, x's and y's are negative. Okay, so let's think about this. We have two different triangles. If you want to call them A and B, that's fine. I have x, I have y, and I have r. R is always, always, always what kind of a number? Positive, okay? If they tell me that I have the sine value, sine is y over r. So I know that y is 3 and r is 5. They tell me something very specific here. Your angle lies in quadrant 1. What do you know about x and y values in quadrant 1? They're both positive. If you use the Pythagorean theorem, guys, what does x equal? Do I need to do it real quick? Okay, so 3 squared plus x squared equals 5 squared. 9 plus x squared equals 25. X squared equals 16. What does x equal? 4. So for my triangle over here, you guys are going to tell me the sine and the cosine and the tangent. What is the sine value here? The sine is what? I didn't hear you. 3 over 5, okay. What is the cosine? 4 over 5. And what is tangent? 3 over 4. That's our y over r, x over r, y over x. Now I'm going to do the exact same thing over here for my beta. Again, you can name it whatever you want. All right, I have x, I have y, and I have r. We just talked about this. If they tell me that the sine is negative 12 over 13, they told me that this is negative 12, and they told me this is 13. How do I know r is not negative? Because r is always positive. Now, they told me that this angle lies in quadrant 3. It's between pi and 3 pi over 2. What do you know about the x values and the y values in the third quadrant? They're both negative, so you know that your x value has to be negative. Using the Pythagorean theorem, guys, x squared plus negative 12 squared equals 13 squared. So x squared plus 144 equals 169. No, r is never negative. So if there's a negative in the fraction, it goes with the numerator. So I have x squared equals 25. So x equals what? 5. It's actually negative 5. Make sure you got that. So for this, my sine is what? Negative 12 over 13. My cosine is negative 5 over 13. And my tangent is 12 over 5. Now, we have not answered the question. I haven't even looked at the question. What are they asking me to find? Cosine of alpha plus beta. So I need the cosine. I need that cosine formula. That's u plus v. Tell me how it goes. Cosine u times cosine v minus sine u times sine v. All right, this is my U, this is my V. You can call it alpha, beta, whatever. So now let's fill in. What is the cosine of U? 4 over 5. And what is the cosine of V? Negative 5 over 13. Agreed? Minus, what's the sine of U? 3 over 5. Times the sine of V, negative 12 over 13. Now I told you guys, at this point, you should be able to stop and look. When I multiply the first, and then I multiply the second, what do you guys notice about the denominators? They're going to be what? The same, which is what we want. 4 times negative 5 is negative 20 over, what's 13 and 5? 65. Now I have minus, right? You guys see how I have minus here? What's 3 times negative 12? Negative 36 over 65. If you have minus a negative, this becomes what? Positive. So what's negative 20 plus 36? 16 over 65. And we always make sure to see if we can do what? Simplify. 23 is the same problem, same type of problem. Solve it the same kind of way. I have the answers already posted for you. All right, let's look at the last. I just put these up just to give a little bit of an extra practice. Let me do 3 and 4 with you guys real quick. These are the multiple angle problems. All right, let's just get a little extra practice here, and then I'll be done, I promise. All right, I want to get the cosine all by itself. So what do I have to do? 2 things. Add 1 and divide by 2. So I'm going to do that. I get cosine 3x equals 1 over 2. Cosine is what value? X values. So I'm looking for the x values on the unit circle that are positive 1/2. Where are they? Okay. So 3x equals pi over 3, and 3x equals 5 pi over 3. These are these multiple angle problems that you have to take one extra step. So I'm going to divide both sides by 3, which in a sense we keep, change, and flip. So this becomes what? Pi over 9. I'm going to keep, change, flip. This becomes 5 pi over 9. Correct? Okay, how is this one a teeny tiny bit different? There's a fraction. Okay, and every one of these so far, what we've done is we've divided by the number. Now we're just going to do the opposite. We're going to multiply. So we want to get, look, the tangent of x over 2 by itself. So do you guys agree I'm going to subtract 3 and then divide by 3, yes? So when I subtract 3, I get negative 3, then divide, I get negative 1. Tangent x over 2 equals negative 1. We're finding the y over x. That gives me negative 1. That would be the root 2 over 2, correct? So where are the 2 places on my unit circle that give me negative 1 as my tangent? 3 pi over 4 and 7 pi over 4. Now, this is a little different from what we did before. This is easier. Sometimes you guys see a fraction, you freak out. This is a little easier. Instead of dividing, guys, what's the opposite of x over 2? What are we going to do? Multiply both sides by 2. Right? So this becomes what? 3 pi times 2. 6 pi over 4. Which, do we leave it like that?
No.
What do I get? 3 pi over 2. Good. So I'm going to multiply both sides by 2. I get x equals 14 pi over 4, which reduces to 7 pi over 2. Good. All right. All of this is posted on Canvas for you guys for your viewing pleasure. So make sure you go over it. I'll post this video on my lunch. I have to Zoom next period.